We're doing question 24. So question 24, that's what we're doing. We are doing question number 24. All right. So we said a resistance of a platinum wire of at ice and steam points are 0.75 ohms and 1.05 ohms respectively. Determine the temperature at which its resistance of wire is 0.90. So what we're looking for is the resistance when the wire is dark. So first of all, what do we do? So first of all, we are going to find like a slope first. So what you do here is resistant at 100 uh minus resistant at ice, that's O, over 100. Okay, now whatever you get or wherever you get, we can call anything once you do this. So what you are doing here is resistance at 100 is 1.05. So you say 1.05 minus 0.75. Once you do that, that is 1.05 minus 0.75 all over 100. Anything you get, we can call that, let's call what you're going to get now theta, or okay, yeah, let's call what you're going to get now Q. Good. Now remember that what you're looking for is the resistance at the temperature theta. Okay, so whatever you get, you plug into this formula. Arrow is equal to RO plus this Q that we've gotten at Q then theta. Okay, that is what we're going to get, Q theta, right? So no, let's see, if we are making theta the sort of formula, what we're going to do is what? We're going to say theta is equal to what? Theta is equal to RO minus RO over Q. Remember, Q is what you got from this first equation. That is Q. That's what you got from that first equation. Then your arrow is your 0.90. Arrow is 0.90. This arrow O is your 0.75. Okay. Then you add it to anything you get from this first equation, and this should give you your final answer. Okay. So next up, we are going to 25. 25 says a bar of initial length LO. Anytime you see L and anytime you see O in anything, just know that that's the initial. So LO is heated through a temperature change. Temperature change is the later temperature remove the earlier temperature. That is it. To a new length L. The linear expansivity A of the bar is what? So that asking you what is the formula to solve when the initial length is heated through a temperature. All right. So what we're going to do is, first off, we'll just write out the main formula. Hmm? All right, so let's go on. So what we're doing here is straightforward. We're going to say L first. Let's bring L. That's the length that is it went to, over LO. So we're equating L over LO will be equals to 1 plus A change of T. Okay, remember we're looking for A here. We're looking for A here, but first of all, let's be doing it step by step. So the next step is L over LO minus 1 is equals to what? A change in what? T. Okay, follow? Change in T. Okay, so we're still on 25. We ran out of space. So we were at L over LO minus 1 is equals to A change in what? Change in T, right? So this can then be equated to A is equal to what? L over LO minus 1 over this whole thing now over change in T. If you do your LCM and you collect your like terms later, you are going to arrive at L minus LO over LO change in T. This will be your final equation. This will be your final equation to solve that question. All right. So let's go 26. 26 says that a thermometer with arbitrary scale S of equal divisions registers minus 30 degrees S at the ice point and plus 900 S at the steam point. Calculate the Celsius temperature corresponding to 60 degrees S. So when it's 60 degree S, what will it be? So first of all, what we're going to do is we're going to have a rationale, and what we're going to use is straightforward. We're going to say 0 degrees, that's ice. Remember that anything 0 C is ice. Then we have over 100. Then we say equals to temperature first at the S, then minus T ice when it's at the ice point over T steam, that's 100. Remember, T steam minus T ice. Remember, what you are looking for is TS. What you are looking for is TS. Don't forget, what you are looking for is TS. And this degree Celsius that we already have here, this degree Celsius we already have here is what we are going to be focusing on. Okay, our T at TS is 60. Okay, so this TS will be 60, this TS will be 60, this T ice we already know it to be what? To be 30. T steam is 90, T ice is 30. So when you do your multiplication and everything, you cross multiply and you get your answer. But this is the formula to use. This degree Celsius is what you are looking for, over 100. we now equate it to Ts. Ts here is 60, T ice is 30, T steam is 60, and T ice again is what? Is 30. That's the equation. Thank you.